All right, we're back. This is going to be page 30 of math analysis, and we are going to talk about how each of the trig functions is periodic. So what does periodic mean? Well, like, think about your life, right? I don't know, maybe you woke up at 7 o'clock this morning, and tomorrow you're going to wake up at 7 o'clock this morning, tomorrow morning, rather, and maybe tonight you'll eat dinner at 6:30, and tomorrow you'll eat at 6:30. It's like periodic, like every 24 hours, you're just repeating the same things. Hopefully you have a little excitement in your life, but some of the things, they just repeat every certain amount of time. That's what it means for something to be periodic. So, for example, like Monday is periodic. It happens every 7 days. Tuesday is the same thing. It's like weeks are periodic. So actually the period of a week is 7 days. It takes 7 days to totally repeat itself. Trig functions are no different. So a periodic function, sort of by definition, is one for which this is true. So we're going to have f of x plus some number is equal to f of x. So for our week, it would be like f of x equals f of x plus 7. Like if you add 7 days, you're just going to be back at the same place. So that's what periodic means. Now what we can do is we can take a look at, how did I already crash this? Okay, so we can take a look at the unit circle, obviously, and use that to figure out the period of our trig function. So we're going to take a look at the unit circle, determine the period of the trig functions. All right, but we don't really have a unit circle. So what can we do about that? Well, what's this? It's a unit circle. Looks like we're going to fill in a unit circle. So get ready, get set. I feel like this is how I start my day every day, filling in a unit circle. It's not the greatest way to start, but you know, it's a start. So here we go. All right, so angles. You must be getting good at this by now. Like, am I getting better? I don't know. I seem to have hit a wall. I mean, maybe if I had smaller handwriting. And then it like hurts. Just going for it. 90 seconds is our goal. I never get it, but it's the goal. I wonder if that's like a function of me getting older. I do think it's a function of me not having written for a really long time. Like I kind of gave up on that endeavor, like handwriting. But I do think I've gotten faster, like in terms of using the iPad at least. Still planning on doing this on paper at some point, just see. That one messes me up. I don't know why. All right, I don't know. When the video's over, I'm gonna go back, I'll check, I'll see. I doubt that was 90 seconds. It's like my eternal goal is to get 90 seconds again. I used to be able to, then, you know, I lost it. Use it or lose it. I lost it. All right, so the whole point of this was that we wanted to look at the unit circle and see if we could use it to determine the periods of the trig functions, right? So let's take a look at, for example, sine, right? So when we look at the values of sine, we're gonna see how long it takes them to repeat. So here we go. So sine's gonna start at 0, because it's the y-coordinate, right? So we're just focused on the y-coordinate. 0 goes to 1/2 root 2 over 2, root 3 over 2, 1. So if the period of sine was just pi over 2, the next value that we get would be 0. And then we would get 1/2 again, root 2 over 2 again, root 3 over 2, and then 1. Then we go back to 0. And you would just keep repeating that. But it doesn't do that. It goes back to root 3 over 2 to 1/2, 0. So if the period was pi, at this point, the next value we'd get is positive 1/2, positive root 2 over 2. But we don't get that. We're still getting different values. So decrease, decrease, decrease. Then it's going to increase, increase, increase. It takes all the way around the circle before we repeat the pattern. So now we are going to repeat then 0, 1/2, root 2 over 2. So the period of sine is just going to be 2 pi. So this is 2 pi. If you look at cosine, there's no reason that that would be any different. So cosine, right, we start at 1, it's going to decrease, 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 but then keep decreasing. So decrease, 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 decrease. Now it's going to start increasing, goes up, 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 and then even more, up, 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 back to the original, and then it's going to go back around. So also going to give us 2 pi. Tangent's a little different. And the fact that tangent is different is going to lead you to get a lot of things wrong. Not wrong in like a you can't understand this sort of way. Wrong in like your brain gets really stuck writing that the period of trig functions is 2 pi, and you just forget, right? So many errors come from the fact that the period of tangent is not in fact 2 pi. So I'm going to write the tangents in a different color. So we get 0, then root 3 over 3, 1, root 3, doesn't exist. Okay, so then you get negative root 3, negative 1, negative root 3 over 3, 0. Let's just keep going. You're going to get positive root 3 over 3, positive 1, positive root 3, doesn't exist. We're going to keep going. You're going to get negative root 3, negative 1, negative root 3 over 3, 0. All right, so we're looking for the period of tangent. Well, look at each half of the circle. I think that's the easiest way to do this. And I want a different kind of color to highlight here. So we go undefined, negative root 3, negative 1, negative root 3 over 3, 0. Root 3 over 3, 1, root 3. Okay, so we went from undefined, negative root 3, negative 1, root 3, negative root 3 over 3, 0, and then just kept going with the positives, right? Once we get there, we kind of like turn the corner, and we're here. So look at this, look along. So we started here to here, and then we go here to here. Those are the same values. Here, 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 here. It actually only takes half of the circle for tangent to start repeating itself. Like if you focus on the undefineds or you focus on the zeros, it's a little easier to see, right? You go from at 3 pi over 2, you go undefined, and then negative root 3, negative root 3, negative 1, negative root 3 over 3, 0, root 3 over 3, 1, root 3. And then it's going to repeat. So it actually only takes half the circle, which means that the period of tangent is different. It's just pi, okay? This is going to cause you problems. You will forget this. Try not to. So try not to forget it, but you probably will because you just get in the zone, like, and sine and cosine, it's like more common to use those. So you get going. So when you get problems wrong for tangent, it's going to be because you forgot the period. And there's almost nothing you can do about it. I mean, it's just like you develop this, you know, your brain like plays the odds. So sine of x is actually going to be equal to the sine of x plus 2 pi. Right? So for example, the sine of pi over 6 is equal to the sine of 13 pi over 6, because if I add 2 pi to pi over 6, same place, right? They end in the same place. They are coterminal angles. This is basically saying that coterminal angles have the same trig values, which we already knew, but you know, it's a big deal actually. So this, and then here, it's going to be the tan of x plus, let's use our obnoxious color again, pi. And we want to not forget that one, but we're probably going to forget that one. Okay, so because it's the last thing on the page, I'm just going to finish this. So we want to use the concept of periodicity to evaluate each of the following. So once you understand coterminal angles, which is really the same as periodicity, you get like anything that you memorize everything for 17 famous angles. You now know it for an infinite number of angles because anything coterminal to any of those 17, you also know. And that's kind of amazing. So let me show you how I do these. So here, I see that this is 20 pi over 3. So I'm going to think. So if it's over 3, 2 pi is really 6 pi over 3. Just multiply by 3 over 3. You get 6 pi over 3. So 20 pi over 3 is really 18. So 3 times 6 pi over 3. That's 3 full circles. And then just another 2 pi over 3. So really, what I can do is I can just think about 2 pi over 3, and the sine of 20 pi over 3 is going to be the same as the sine of 2 pi over 3, which is the y-coordinate of the point, which is the y-coordinate of the point on the unit circle. So it's just going to be radical 3 over 2. Cosine of 20 pi over 3 is going to be the same as the cosine of 2 pi over 3, which is the x-coordinate of the point. And then the tangent is going to be the same as the tangent, which it's pi over 3 and it's second quadrant, so it's going to be negative, and then radical 3. So this is how I use this idea. You can also do the thing where we find the principal coterminal angle. I mean, that's essentially what I've done, but I think it's easier conceptually to just think like, what would be 2 pi and how can that help me? So here, I'm going to think that 2 pi would be 8 pi over 4. And so 8 pi over 4, what's the closest multiple of 8 to 53, basically, is what I'm looking for. So 56 is like a little too big, so I'm going to go with 48. So 48 would be 6 times 8. Oh, well, let me start with the angle. All right, so 53 pi over 4 should be 6 times 8 pi over 4, which is 48 pi. And then what do you add to 48 to get to 53? You'd have to add 5 pi over 4. So we just kind of dissected this down to its principal coterminal angle. The key thing, though, is that the sine, cosine, and tangent of 53 pi over 4 is the same as the sine, cosine, tangent of 5 pi over 4. That's what we want to use here. If you don't like this, go back and watch the videos about finding principal coterminal angles and just do that. Like, not a big deal. Totally fine. But I'm going to do this. So 5 pi over 4, quadrant 3, so, and it's a pi over 4, so those are the easier ones to remember, I think, because you kind of like can't go wrong. I mean, you could. In fact, I often go wrong by putting the wrong thing in the radical, despite my brain knowing that there should be a 2 in there. I often want to put a 3. I don't really know why. All right, so this one's interesting, right? So I'm going to think of 2 pi as 12 pi over 6. I don't know why I said 3. There was a 13. It made me think of 3. So because I know that sine is odd and cosine is even, I could just think of this as negative 13 pi over 6 is equal to 1 times 12 pi. So what am I doing here? I'm trying to explain what my brain is thinking about this. Here's what I'm thinking. If I add 12 pi, so if I add 1 rotation, this is what I wanted to say. This gives me negative pi over 6. Now that is not the principal coterminal angle, so I'm going to use a different color to highlight it. Not, oh, well, I've been doing that for all of them, it turns out. So in fact, I will highlight it in a different color, and then I will make a note that this is not the principal coterm. But it's enough information because I know that the sine of negative pi over 6, sine is odd, right? So it's the negative of the sine of pi over 6. So I could actually, just because I know that sine of pi over 6 is 1/2, this would be negative 1/2. I know that the cosine of negative pi over 6, because cosine is even, is equal to the cosine of pi over 6, which is going to be what is this little shape here? Is going to be equal to radical 3 over 2. And then I know the tangents of pi over 6 angles are radical 3 over 3, but negative pi over 6 is actually a quadrant 4 angle, so tangent should be negative, or sine over cosine, definitely going to be negative in this case. So you could have done it that way, which is, I think, how I would have done it. Alternatively, so let's say, or you could say that, what do I want to say here? I want to say that negative 13 pi over 6 is equal to I mean, it's, well, okay, so it's 11 pi over 6. This is part of why I don't like this. 11 pi over 6, and then minus 2 times 12 pi over 6. You see how I'm struggling to just justify it even? Like, it shouldn't be a struggle. I'm just, having a little trouble articulating this idea. This is what you would need to do, right? Another thing you could do, which is basically what I did because I couldn't work out what was happening, is you could have done this. So for this one, you could have said negative 13 pi over 6 plus 12 pi over 6 is negative pi over 6. Not good enough. Negative pi over 6 plus, I just keep adding rotations, equals 11 pi over 6. Good enough. That's the principal coterminal angle, and then you find everything for that. So either way, this page ended up pretty colorful. And what we're going to do is stop here. And that's periodicity, right? Periodicity. Something that repeats over time at regular intervals is periodic. So I'm going to cut this here. I'll come back in the next video and do more, and I will see you there.